All right, everybody. So to start this video, let's again talk about where we've been and where we're going, just to connect it all together as we go through these videos. So in the last video, I talked about the rules for calculating an antiderivative, and we saw different applications of these rules and looked at problems that were all different. And let's say that we got that down, practice that, or we understand it, it's no big deal. Now I want to talk about more difficult problems, okay? And I put difficult in quotes because if something's difficult or not is just a matter of opinion. And you might not think this one is difficult, or maybe you will, who knows, okay? But I think this kind of problem tends to be more difficult for people because the problem is not just given to you. You have to read the information, figure out how to assimilate it, what to do with it, what's important about it, what's not important about it, how to use the information, and then solve the problem from there, okay? So let me read you how the problem is given, and then I'll tell you how I would think about it, okay? And then if you like that, you can think about it that way too. So it says, find the equation of the curve whose tangent line has slope of f prime is 3x to the negative 4/5 power, given that the point -1, -4 is on the curve. Okay, so you got to take that information in, like I said, and understand what you're being told and what you're going to do with it, or even what you're looking for. Like, what are you trying to find here? Okay, and it says find the equation of the curve, but it's like, you know what that means in this context. All right, so I'll tell you how I think about it. I'll think about it like this. There's a curve, which I've just drawn generically right here, and I don't know the equation for it. I don't know the formula, okay? I know that the derivative of that is 3x to the negative 4/5 power, so I know that much, and I know this point is on the curve. So that's like all the information I have. And I guess like I could see it as that I'm looking for this, okay? What is the equation of that curve? All right, so we boiled it down to that. We know the derivative of this function, and we know this point satisfies that function, that this x and that y fit and work into that function's equation. All right, so let's break this down into two steps. One, if I know that the derivative of this function is 3x to the -4/5, then the function itself is the antiderivative. Okay, so let's break down into steps like this. So step one. Okay, this function f of x that I'm after would be the antiderivative of this. Okay, and in order to calculate that, I have some rules at my disposal. And again, I talked about those rules in the last video, but those rules would tell me to do this. That 3 right there, I carry into my answer in my work. As far as this x, this variable to this power, I'm supposed to add 1 to the power. Okay, so I get -4/5 plus 1, and then I divide by that very same number, -4/5 plus 1. So carry the 3, and then for this variable to this power, add 1 to the power, so on. And then I have my constant of integration, plus c. Okay, as far as that goes, let's clean this up a little bit. I'll get a 3. What's -4/5 plus 1? -4/5 plus 5/5. So that's going to be 1/5. So 3 times x to the 1/5 power divided by 1/5. Okay. Plus c. And then what about this? I'm multiplying by 3, but I'm also dividing by 1/5. Now, when you divide by a fraction, you multiply by the reciprocal. So I don't have a 3 divided by 1/5. I've got a 3 times 5. So I'm going to get 15 x to the 1/5 power plus c. Okay, so it's like I've got a partial answer. This is not the full final answer yet, but that function f of x, whose derivative is 3x to the negative 4/5 power, is 15 x to the 1/5 power plus c. Okay, so that's a partial answer. Why is that only a partial answer? Well, because if I'm looking for the equation of this curve, it wouldn't have this unknown constant in it. Like, to fully know it, I would know what all the numbers were. Okay, now this capital C is a constant of integration. And we go all the way back to the first video to learn about the constant of integration, but remember, it's like the antiderivative of 2x is x squared, because the derivative of x squared is 2x. The antiderivative of 2x is also x squared plus 17, because the derivative of x squared plus 17 is still 2x. That's why we have that constant of integration. So, you know, for me to go through this first step, I know everything but that number, that capital C. Okay, so let's say that here's where we are now. So we've narrowed it down. We've got a partial answer. Maybe we're like almost all the way there. And now it comes down to this. Now, what's this? What's this constant of integration? Okay, all right. Well, that's where this known point comes into. Because think about it. If this point is on that curve, that means for this function, if you put -1 for x, you will get -4 for y. I can use that information to find this constant of integration. Okay, so let's do this. Let's say, proceeding to step 2, that I'm going to use the known point. And then I'll have it. Okay, that known point is that x is -1 and y is -4. So it means in this equation right here, the equation for the curve, I will get -4 for y if I put in -1 for x. And that will be just enough information to find this unknown constant of integration. All we know is that it is a constant. Okay, it doesn't reveal itself on its own. But if I use this known point, I'll find it. So look, all right, let's do calculations. We'll figure out what that number is. So I just get -4. And let's say if I calculate -1 to the 1/5 power, that is also -1. So I get -15 plus c. And then if I solve for c, say I add 15 both sides, then I'll get 11. Okay, so c is equal to 11. So then I've got my full answer. The function, the curve, is 15x to the 1/5 power plus 11. All right, so let's give our answer up here. Because I kind of mapped things out up here. I wanted to know the equation of this function, this curve, whose derivative is 3x to the -4/5 and also has this particular point on it. And now I have it. It's 15x to the 1/5 power plus 11. Okay. So maybe, like, once you get down to it, it's not that difficult of a problem. Okay. Why I might call it difficult is because it could be difficult to read through this information, like I said at the beginning, and figure out what to do with everything and figure out what you're trying to find. Okay. All right. Now, so I think that's a big skill in math, is being able to do that. It's often not that hard to go through procedures in a rote way when you just practice them over and over again. What the real skill of math is, I think, is in problem solving and taking something that's all jumbled together, having to take it apart and put this here and that there and figure out what to do with it. That is what I think is actual talent in math, and that's what I'd like you to practice.